Hey guys, this is Carrie, and in this video we're going to be talking about the graphs of higher roots. So I should have changed the title here, sorry about that. Alright, so we're going to be considering the function f of x is equal to the square root of x plus 4 minus 5. What inside and outside transformations does this function have? Alright, so looking at it, the key idea with an inside transformation is those are happening inside of the function. In this case, inside of the square root. So here we've got an inside transformation of plus 4, because that's underneath the square root with x. It's inside of it. All right, so that's our inside transformation. And we have to remember inside transformations always affect the x direction. So it's either going to be moving it left or right along the x-axis. And for those of you that missed last class, what we learned is that there is an overall shape to these square root functions. Let me just draw that. And it starts off here, and then these numbers, the plus 4 and the minus 5, are going to move it around up and down, left and right. All right? So this is inside transformation is always going to move it in the x direction, and inside is always in the opposite of what we expect. So in this particular case, plus 4 is going to move it. We would expect if we had to choose left or right for plus 4, we would think right, but it's always going to be the opposite of what we expect with an inside. So inside transformation here is plus 4, or plus 4 to the left. So we're going to move 4 left here. All right, next up we've got our outside transformation, minus 5. And outside transformation is the opposite of inside in all respects. It's called an outside transformation because it's outside of the square root. And it also affects all the opposite things. So this one's going to affect the y direction. It's going to move it in the y direction, so either up or down. And it's as expected. So in this case, minus 5, if you had to pick up or down for minus 5, it seems like it will be down 5. So the inside transformation takes us left 4. The outside transformation takes us down 5 because it's minus 5. And then we have that exact same overall shape that we're drawing here. So minus 4, minus 5. All right, so to see some of the details of this, we can look at this multiple choice problem here. Which of the following is the graph of square root of x minus 3 plus 5? We identify our inside transformation. This will be either left or right, right? Minus 3 feels like it should be left, but inside transformations are always the opposite of what we expect. So we're going to say that this will move us right 4. And then here we go. We've got plus 5 as the outside transformation. Outside is always the y direction, so either up or down. And in this case, we've got plus 5, so I think that's going to be up 5, because y is as expected for the outside transformations. All right, so we start with our overall shape here. Essential starting point at 0, 0, weird little square root wave shape. And then what we're going to do is we're going to test these out. So we're supposed to be moving right 4 and up 5. Right 4, up 5. No way, that's totally off. Okay, starting at 0, 0 here, right 4. Oh, sorry, oh, I can't count here, guys, sorry. Hopefully you caught that already. That should have been right 3, because it's a minus 3. What was I talking about? Right 3, up 5. Nope, that doesn't work. Right 3, up 5. And what's important is, as I'm checking these, the fundamental shape, square root of x, always starts off at 0, 0. So here we go, right 3, 1, 2, 3, 4, 5. This is the one. It's got to be choice 4. And if we're looking for some vocabulary to describe what's happening here, we can really think about that vertex shift. That vertex shift is going to be representative of the shift of the whole graph. So here our new vertex is 3, 5, because we moved right 3 and up 5. All right, so the key points from last time's lesson were these inside transformations, x direction. Left or right. Sorry, right or left. And it's always the opposite of what we expect. Outside transformations, That's going to be the y direction. Y direction is either up or down, and these are as expected. Those are like bullet points. Those aren't negative signs. Let me just draw those as bullet points. Sorry about that. All right, here we go. Bullet points. All right, so one of the amazing things about what we learned last time is you might be thinking, okay, well, great. This really helps me for square root functions. It lets me graph them without the calculator super fast. But it actually turns out to be even more powerful than that. These rules actually work for all functions. So as we go through the year, we're going to be studying a whole bunch of functions. We're going to be studying things like parabolas. These will have the same shifting rules as these. Square roots obviously do. You might remember from Algebra 1, absolute value functions have the same shifts with inside and outside transformations. Every function type actually follows these rules. So let me just make a note of this. This is a super powerful idea that's going to help us graph any function shape. This is true for all function types. So these shifts are going to be useful throughout the whole year that we're learning today and last class. The one thing that's going to change is when our function type changes, for example, square roots, we've learned that they have a basic shape starting at 0, 0 and having that crest going up, that like wave. For cube roots, actually, it's going to be the same inside and outside transformation rules. It's just that the overall shape is actually different. So this one has a key point at 0, 0, just like our square root one did. And to remind you what the equation looks like is this. Cubed root of x. When you see this cubed root, what that's going to mean is, okay, well, instead of having this shape, the square root shape, you're going to have the cube root shape, which looks very similar. It's got, it's automatically turning into a straight line. It's got this shape here, and then it also has a negative part there. And so the cubed root shape is going to be this piece, like that. And again, we're going to focus on where does this 0, 0 point move. And it will be the same rules as last time with inside and outside transformations. So let's see an example of this in action. On the grids below, draw rough sketches of each of the following functions. Make sure to label the vertex with its coordinates. So it turns out that being able to draw a rough sketch is really useful, and it will allow us to go much faster than drawing with the calculator or anything wild like that. This one is going to have a square root shape, first thing we know about it. So I'm actually just, and I don't know if you should do this, because you don't really have the ability to move it like I do, but I'm going to draw my square root shape there. Now thinking about the transformations, we've got a -7 inside of the square root. So this is going to be, we would think left 7, but it's actually the opposite. It is right 7. Okay, so we're going to move it 1, 2, 3, 4, 5, 6, 7 to the right. And then an outside transformation of +2. Outside is as expected, so this will be up 2. So then what we can do is, I mean, this is really amazing, right? We haven't used the calculator at all. We just shift the square root shape 7 to the right, up 2, and our new vertex here is at 7, 2. So when we see these functions without using the calculator, we can already get a really good mental picture of what they're going to look like, and that can really help us solve problems like problem number 4 here, which we're not going to look at yet because we've got 1b, 3b here. Okay, so for f of x here, cube root of x plus 3 minus 4. All right, well, the first thing to identify here is we no longer have a square root. We've got a cubed root. So overall shape is going to be that cubed root squiggle. Okay, so we know that's our overall shape. And we know that usually it starts off at 0, 0, so maybe I'll place it on the graph. Not worrying about the details too much here, right? We could graph point by point. But the goal here is to just get a nice picture of what it might look like that will allow us to answer more complex questions later on. All right, so thinking about our shifts here, +3 inside feels like it should be right 3, but we know better. inside is always the opposite of what's expected. So this will move us left 3. So we're going to go 1, 2, 3 units to the left. And then we'll go here, outside transformation -4. My outside is the best, it's my favorite. It's as expected, so we'll go down 4. So 1, 2, 3, 4. All right, so the nice thing about this is we're just going to take this overall shape, this green shape here, and instead of starting at 0, 0, we can focus just on that single point, because if we move that single point, it's going to move the whole graph with it. So we'll go left 3, 1, 2, 3, down 1, 2, 3, 4, and it shifts the whole graph by just focusing on that single point there. All right, so we've got the new vertex of this thing is at left 3 would put us at -3 for the x-coordinate, down 4 is -4 for the y-coordinate. And this overall picture, sure, it's not as accurate as a calculator-based graph, but it gives us a lot of key information and allows us to look at a problem like this and see a mental picture of it before we do anything with the calculator. All right, so here's a type of problem that is ideally suited for the skills we've learned, that might come up on the Regents, and is just like kind of like, you know, you might look at it and be like, well, how do I do that? Well, to me, the easiest way to do this one is if we're looking for the domain and range, this idea is really connected to the graph of the function. Because thinking about domain, that is all of the included x values. Now, it is very hard for me to see what x values would be okay here, just looking at the function. So what we're going to do instead is we'll look at the graph. So here are our axes. This one is going to be a square root style function because it's just the square root. So we know it's going to be like a little wave. It's going to be 5 to the right, opposite of expected. 2 up. So we go 1, 2, 3, 4, 5 to the right, 1, 2 up. And we draw our little wave here. 5, 2. Now notice that there was nowhere in the problem that told me to graph this. It's just a really helpful thing to have this nice picture of the problem though. Now the reason why I find this so helpful to have this graph, this picture is, if we're looking for all of the included x values, what we can think about is, well, sorry, I want to get this whole, actually I can't really get the whole line, so I'm just going to stick with this part. These x values over here are not on our graph, so we're going to ignore them. But we keep shifting to the right. The first x value that we hit that's on our graph is -5. So we know that our domain starts off at -5. Now, if we continued on in the x direction, that arrow here, on the pink arrow here on the square root function means this graph actually continues this way forever. So there is no highest x value, which means that x goes all the way from -5 to infinity because there is no highest x value. That arrow means it goes forever in that direction. So what we can do with the parentheses here is we'll say -5 is included. And one thing that's important about infinity is we can never actually reach infinity, because if you could hit infinity, you could go past it. And infinity is supposed to be this idea, this thing that's sort of represents beyond all numbers, something that you can't go past, an infinite amount of numbers. So we'll put a regular parenthesis there using our interval notation. I made a mistake here, right? I hope you caught it. It doesn't start at -5. Our interval starts at 5, so we want to make sure we use that, not the values from our function, because 5 was the starting x value right here. All right, so we're going to do the same thing with the range. And maybe we don't have to do it with the whole line thing this time. What's the lowest y value that our function hits? The lowest y value is 2. So we know that our range will start at 2. This arrow here means our graph is actually not just going right forever, but slightly up forever as well. And if it's going up forever, there won't be any maximum y value. So we'll say that it approaches infinity on that side as well. So just remember that range is y values. And notice that we were able to solve this question with no calculator. Kind of the graph very simply gives us the key values of 5 and 2. All right, so you're going to be practicing this the rest of the period. You've got some nice practice problems with a variety of different function types, so lots of square roots. Make sure with cube roots you change your shape. And for cube roots, I've noticed in the past that students often have a hard time identifying that key point in the middle. So for these ones, that key point that you're going to be looking at is this point in the middle of the twist, and that will correspond to the point that's usually at 0, 0 until you have it shifts. All right, I think you guys are ready to solve these. So good luck, and hopefully you get the practice you need to be able to ace these question types, because these are super useful. These things will come up throughout the entire year with inside and outside transformations. Bye guys, hope that was helpful. See you in class on Friday.